This is a video for section 2.4 on problem 7. So let's get there. Okay, so the first thing I'm asking in 7 is part of the Guth check. We're going to see in parts A and B if we would expect infinity and negative infinity to be part of our solutions. And what that means is if I plug in huge values for x, will that make this inequality true? So, I mean, obviously values go way higher than 1 million, but let's think of putting in something like 1 million. So say I were to put in 1 million for x, and 1 million plus 1. And again, we're seeing, does this make the inequality true? And thinking about when I put in huge values for x, the constants right here, -4 and +1, become pretty insignificant compared to everything else. So you're really going to be left with something, in this case, 7 times huge, like 7 million, say, over 3 million. And what will that reduce to? It'll reduce to 7/3. And is 7/3 greater than or equal to 2? It indeed is. So I would expect infinity to be part of my solution. We do the same thing for putting in negative huge. So if I think about putting in negative 1 million for x, that would reduce to, again, the -4 and +1 will become insignificant. So think about -7 million over -3 million, which is still 7/3, which is still greater than or equal to 2. So I'm going to expect both positive and negative infinity, excuse me, to be part of my solution. Okay. Now, going about solving this inequality, I cannot multiply to clear the denominator for 3x plus 1, multiply both sides by 3x plus 1, because 3x plus 1 could take on both positive or negative values, depending on what x is. And because of that, I wouldn't know, do I keep the inequality sign? Do I switch it? So instead, the easiest way to deal with that is to bring everything to one side and make a common denominator, and let's do sign analysis. So subtracting the 2, and then making the common denominator, which is going to be 3x plus 1. All right, greater than it. So let's just distribute that -2 to 3x plus 1 and combine like terms. So that will leave you with x minus 6 on the top over 3x plus 1 in the denominator. And remember what goes on a sign chart, always where the numerator equals 0, 6. And I'm going to fill in the circle because it does include equality. So it does include when the whole fraction is 0, which will be at 6. And then the denominator is never closed circle because you don't want, denominator can't be 0. So we're going to put an open circle. And then if I plug in a values greater than 6, like 7, it'll make this quotient positive, and then it should alternate in this case. And you can always plug in values if you're unsure for the different intervals. So looking at, and I go back to my inequality, I'm looking for where greater than or equal to 0, so the positives. So my solution will be negative infinity to -3rd, union bracket 6 to infinity. And sure enough, that checks out with the Guth check of I anticipated negative infinity, and infinity should be part of my solution. Okay, so that was 7. Let's do a similar thing for 8. Do a different color here. In 8, again, the Guth check, thinking I'm plugging huge values in for x. And I do have, notice my left side is still the same as it was in 7. So the fraction when I plug in huge values of x will reduce to about 7/3, which in this case is not greater than or equal to 3. So I am not going to anticipate it going, infinity being part of my solution. And how about if I plug in negative infinity for x? Will that make this inequality true? It will not, because it also will reduce to 7/3, which is not greater than or equal to 3. So I'm not anticipating either infinity or negative infinity being part of my solution. Okay, so let's go about as we did 7. Let's bring the 3 to the other side. Common denominator, so I'm going to have 7x minus 4 minus 3 times 3x plus 1 over the 3x plus 1. And distributing and combining like terms, I'm going to get, let's see, how many x's? Looks like I'm getting minus 2x, and then minus 4, minus 7, 3x plus 1, greater than or equal to 0. On my sign chart, I've got negative 1/3, open circle, and then close circle at negative 7/2. All right, if I plug in something greater than negative 1/3, like 0, I'm negative, then it will alternate here. And so my solution, I'm looking for where it's greater than or equal to, so the positives. So my solution to this piece is negative 7/2, negative 1/3. And sure enough, notice infinity and negative infinity aren't part of that solution.